Hello everyone, Rob Rizzuto here from BAE News. This quarantine has caused my hair to go all crazy as you can see, but we're still chugging along here. Today we have two scientists from NC State University here to talk about wetlands. Now, what is a wetland?
Land. Wet. Wetland.
So apparently that was really wrong, so I turned to the internet to figure out what a wetland is. The wetland that these two scientists are going to talk about today is a constructed wetland. This wetland is designed by scientists and engineers to treat wastewater. The wastewater that's being talked about is municipal wastewater. There are two main types of municipal wastewater, gray water and black water. Black water comes out of all of the toilets in the area, and it has all that stuff in it, and that goes into the environment. Gray water is the water that comes out of bathtubs, showers, sinks, washing machines, and all other kitchen appliances. The wetlands treat these two, but I don't know how, being that I'm just a news anchor, but that's why Mason and James are here. Now over to you, Mason.
Thanks, Rob. I'm coming to you guys today from out in the field, but staying safe and avoiding the virus, so let's get right into it. Most wastewater is full of nitrogenous compounds that have the potential to cause oxygen depletion and be toxic to organisms in aquatic habitats. And while wetlands are very efficient in organic matter removal, and are even referred to as the kidneys of the earth, they often underperform in nitrogen removal. Constructed wetlands are very cost efficient as they don't require electricity or human labor, and they're cheaper to construct and maintain. So there's two different types of wetlands. There's surface flow and subsurface flow, which I have diagrams for right here. And surface flow are 0.2 to 0.6 meters deep, and they have dense vegetation and are very shallow, so sunlight easily reaches the bottom to promote algae growth and photosynthesis, and these are most common in North America. Subsurface flow wetlands are more of an impermeable ditch with gravel and soil to promote plant growth, and they're mainly used in Europe and Africa. So there are several biological techniques used for nitrogen removal. And the first one is ammonification, which is when nitrogen is biologically converted into ammonia in reed beds, and this occurs fastest in oxygenated zones. And second, we have nitrification, which is when bacteria such as Nitrosomonas and Nitrobacter remove ammonia. And it's very oxygen demanding, and it's followed by denitrification. Denitrification uses nitrate as the terminal electron acceptor, and bacteria turn inorganic nitrogen, like nitrate and nitrite, into nitrogen gas, or into. And it occurs in anaerobic zones, and I have both of those processes laid out right here. And for constructed wetlands, microsites with deep oxygen gradients can be created, so nitrification and denitrification can occur sequentially. And so plants can also uptake inorganic ammonia and nitrate, and most of these reactions occur in the rhizosphere, which is the narrow region of soil containing the root microbiome, which consists of root secretions and associated microorganisms. Physiochemical processes such as ammonia adsorption and sedimentation also contribute to pollutant removal. And now I'm going to send it back over to James.
Now that we know how constructed wetlands impact the nitrogen problem, let's discuss more about the problem with the nitrogen problem. If the wetland becomes too loaded with organic matter and ammonium, the kidneys of the earth, as they are known, will fail to work. The ammonium will demand oxygen to create nitrate, and we don't want nitrate since that's what we're trying to remove from the system. And we don't want the oxygen demand that comes with it, since the denitrifying bacteria need an anaerobic environment. What we want is reduction in the form of denitrification, which removes the nitrate in the form of nitrogen gas. But reduction can't take place if the wetland is already full with already reduced compounds. However, constructed wetlands are not the typical way of filtering out pollutants. In most instances, municipal water treatment plants are used, but which one is really better? One very important thing to consider is cost, lifetime cost, which is the cost to take to build, but then continue to run and maintain something over time. When you look at a constructed wetland, they may have to be dug out if they get too full of gunk, or they might be overrun with invasive plants. So plant maintenance is important. But their biggest cost is actually land acquisition, because they take up more space than a municipal plant does. On the other hand, while municipal plants require way less space, they do require a lot more energy input for both electrical and mechanical for the pumps and other needs. As you can see, I mean, there's a lot more movement up here than there is down here, but a lot more space down here than up here. The wetland down here doesn't need any pumps and is gravity fed and requires much less energy. In order for a constructed wetland to perform slightly better as far as phosphorus, nitrogen, and solid removal than a municipal plant, it would need to be about twice the size of the municipal plant. However, it would be about $80,000 cheaper initial cost to build, as well as being $1,700 cheaper maintenance every single year. Another plus for constructed wetlands, if they're maintained properly over time, is they're a great habitat for different species, which promotes biodiversity, which in turn actually increases the quality of water in the area. That's all I got for you. Back to you, Rob.
Thank you, Mason and James, for teaching everyone about constructed wetlands and how they treat municipal wastewater. Now I'm Robert Rizzuto from BAE News. Everyone stay safe and have a good night.